Okay, so in this video we're just going to look at example 14 from the text. And so we have, this is basically finding, taking a quadratic equation and converting it to this y equals d bracket x minus h all squared plus k form, or the translation form I guess you could call it from what we were looking at before, but it's also known as the turning point form. So, because the reason it's known as the turning point form is because the turning point coordinates are easily accessible, h and k. So we've got here, for the quadratic function, y equals x squared minus 6x minus 1, a. Complete the square and write the function in this form. So you'll need to know how to complete the square to do this, but let's just move over the side here and we'll do it ourselves. X squared minus 6x minus 1, y equals x squared minus 6x. Okay, so now it's a little bit different to factorizing it by completing the square, but the same sort of process. So first we want to get our b coefficient, or our x term coefficient, and that is negative 6. So what we want to do is halve that, which half of negative 6 is negative 3, and then we want to take that number and square it. So negative 3 squared is 9. Now what we do next is we add that 9 to our equation, but unlike before where we added the 9 to both sides because we had something on the left and something on the right, in this case what we do is we add the 9 after the 6x, so we're adding it in here, but then, so we're not actually changing our equation, we also take away 9. So we add 9, take away 9, essentially we've changed nothing. Now, if we had our constants on the other side like before, well, taking away 9 from this side is the same as adding it to the other side. So we're doing the same thing we were before, just on the same side as just on the other side, I guess. Now we have here x squared minus 6x plus 9 perfect square. So we get again our half of the x coefficient here that we got before. That's going to be in our brackets. So y equals x minus 3 all squared. And now if you expand that out, x times 3 is negative 3. That happens twice, gives us negative 6, and negative 3 times negative 3 gives us plus 9. So that expands out correctly. And then don't forget our negative 9 and negative 1 here. We can simplify that to just negative 10. So that's it. In this case, our d value here is 1, and so that is our equation in turning point form, or this form. Now they've asked us next to write the equation of the axis of symmetry, x equals h. Well, we had our thing in this form. Here's our h value. So the thing with this is, let's go back to here. Here you'll notice it's negative h. So this h value, because the form itself has a negative in front of it, this h value is actually just the 3. If for example we had x plus 3, well that would be, all squared say, that would be equal to x minus negative 3 all squared, because this negative would come from the form itself and this negative would be part of the h value. But in this case we have the negative 3 here. The negative comes from the form of the equation, so our h value is just 3. Therefore h equals 3. Therefore the equation of the axis of symmetry, as said in the book, is x equals h, and which in this case is x equals 3. So the equation x equals 3, remember, when it's only got one variable, it's independent of the other variable. And if we have the value x equals 3 here, the equation x equals 3 is a vertical line that goes through the 3 on the x-axis. Now the other thing we were asked to do is find the equation of the axis of symmetry and the coordinates of the turning point. Oops, I discussed the wrong part before. But anyway, I was talking about this before, which was the answer. So we've found the equation of the axis of symmetry, that's done, and we need the coordinates of the turning point. So the coordinates of the turning point, as discussed, is just the point HK. Now if we go over here, H was 3, but in this case, K, well, we have negative 10 here. The form itself that we were discussing is positive K, or plus K. So this negative 10 is actually equal to plus negative 10. So the positive being part of the form, but the negative is actually part of K itself. So in this case, HK equals, and H was positive 3, and K is negative 10. So our turning point is at the point 3, negative 10.